Okay, so let's say you're getting ready for this big senior software engineer technical interview,
Mm-hmm.
and you're thinking about that system design
Right,
part,
right.
and you know it can feel a bit like well, trying to drink from a fire hose sometimes. Yeah.
Yeah, a lot to cover for sure.
So it would be really helpful to kind of zero in on
Yeah.
one area that can make a huge difference
Right.
in your interview, and that's system reliability.
Exactly. And we're not just gonna, give you the same old tired interview tips.
Yep.
Think of this as like a deep dive,
Mm.
into the real core stuff, the principles that really make a system strong and dependable.
Yeah.
The kind of stuff that senior engineers are expected not just to understand, but to actually, build with.
And that's really the key, right?
Yeah.
Because at the senior level, interviewers want to see
Yeah.
that you're not just writing code that works in a perfect world.
Right.
They want to see that you can think ahead,
Yes.
that you can imagine what might go wrong.
Yes.
And, design a system that can handle it,
Right.
even when things go sideways, as they inevitably do.
Yeah, that's the reality, isn't it?
So let's jump right in.
Okay.
When we talk about system reliability in software, um, what are we really talking about? What are the big things we need to keep in mind?
Well, I think at its heart, a reliable system is one that just does what it's supposed to do
Mm-hmm.
consistently, right? It delivers what users expect.
Makes sense.
But that's just the beginning, really.
Okay.
Reliability is also about how the system deals with stuff you don't expect. Like
Right.
when users do things, they're not supposed to.
Yeah.
Or when you have a ton of people all using the system at once.
Right, under heavy load.
Exactly. And it's about keeping the bad guys out, right? Protecting against unauthorized access.
Right, security is part of reliability.
Absolutely. And maybe the most important part is, can the system keep working even when things go wrong internally? Or, when there's some problem from outside?
So it's not just can it run perfectly in a lab.
No.
It's can it handle the real world
The messiness of the real world.
with all its imperfections.
Yeah, you got it.
Now, I know there's something we need to clear up right away,
Yeah.
especially for anyone prepping for these interviews, and that's the difference between faults and failures.
Oh, yeah. That's a classic, isn't it?
Can you walk us through that?
Sure. So a fault is like when some part of the system, it's not behaving the way it should.
Okay.
It's like a little hiccup somewhere.
A localized problem.
Yeah, like you might have a bug in the code somewhere, or maybe one service is misconfigured.
So it's an internal thing.
Yeah, it's internal.
It might not even affect the users yet.
Right.
Kind of like, if you had a big machine with a bunch of sensors, and one of those sensors is giving bad readings.
Yeah, perfect analogy.
The machine might still be working,
Right.
but there's a problem brewing.
Exactly.
Now, a failure, on the other hand.
Yeah, so a failure is when the whole system, from the user's point of view, just stops working.
Okay.
That's when you get an outage, users can't get in, or, the system just slows to a crawl.
So it's the point where those little internal faults
Right.
actually become a big problem for the user.
Exactly. It's the impact, right?
So a fault is like the cause.
Yeah.
And a failure is the effect.
I like that. Yeah. Cause and effect.
And understanding that difference, I think that shows a more kind of systems level thinking, right?
Absolutely.
You're not just thinking about one little piece of code.
Yeah.
You're thinking about the whole system.
The big picture.
And how all the pieces fit together.
Right.
Now, the thing is,
Yeah.
we can test and test and test and try to write perfect code.
Sure.
But in the real world, in a complex system,
Yeah.
we can't eliminate all the faults, can we?
It's impossible, right? There's always going to be something.
So instead of trying to be perfect, we need to design systems that can tolerate faults. That can keep working even when something goes wrong.
Yeah, that's where resilience comes in, right?
It's about redundancy.
Yeah.
It's about having backup plans
Absolutely.
and being able to kind of absorb those shocks.
Exactly.
Now, something I was reading about that really surprised me was
Yeah.
how often system outages are caused by human error.
Yeah.
It's not always the code.
Right.
It's not always the hardware.
Sometimes it's us.
Yeah, sometimes that's us.
And, we've got all this amazing technology these days.
Right, automation, AI.
Yeah, all that stuff.
But human error is still a major cause of downtime.
It's a big one.
I was reading that misconfigurations by operators, people were making mistakes in the settings.
Right.
That can be a leading cause of outages.
Yeah, especially in these big internet services.
And sometimes even more common than hardware failures.
Yeah, it's kind of scary when you think about it.
It is a little scary.
Yeah.
Because it means that even if you have this amazing technical architecture, you know, rock solid code, perfect hardware.
Right.
One little human mistake can bring the whole thing crashing down.
It can, and it does happen more than you think.
So how do we as engineers account for this human factor?
Right.
What are some strategies that we can use to try to prevent these mistakes?
Okay, well, one really important principle is to design systems that are easy to use.
Okay.
Not just for the end users, but for the people who operate the systems.
Right, the administrators, the other engineers.
Exactly, the people on the inside. So you want to make the interfaces clear and intuitive.
Right.
You want the APIs to be easy to understand so people don't make mistakes in the first place.
So it's about making it harder to mess things up.
Yeah, exactly. Like you want to have helpful error messages.
Yeah.
You want to have sensible default settings.
Right. And good documentation so people know what they're doing.
Exactly. Make it foolproof as much as you can.
And, you know, it's not about treating people like they're stupid.
No.
It's about recognizing that everyone makes mistakes.
Right.
And trying to design systems that are forgiving.
Absolutely.
So it's like having those safety rails built in.
Yeah, I like that analogy.
Now, another thing I was thinking about was, you know, even with the best design, even with great user interfaces, people are still going to make mistakes.
That's life, right?
Right. So what do we do then? How do we make sure that we can recover quickly when something does go wrong?
Okay, so one thing that's absolutely essential is having a really good rollback mechanism.
Okay.
And this goes for both configuration changes and for software deployments. So if somebody makes a change to the configuration and it breaks things, you need to be able to quickly and easily go back to the way it was before.
So it's like an undo button for your system?
Exactly, a big giant undo button.
I mean, that's got to be reliable, right?
It has to be rock solid.
If that undo button doesn't work,
yeah, you're in trouble.
You're in big trouble.
Big trouble.
Now, another thing that can really help is gradual code rollouts. So instead of releasing a new version of the software to everyone all at once, you roll it out slowly.
Right.
Maybe to a small group of users first.
Exactly.
Or to a subset of your servers.
Yeah, there are a couple of ways to do this.
Yeah.
You've got things like blue-green deployments. And feature flags. And these give you a lot of control over how you release new code.
So it's like dipping your toe in the water before you jump in the whole way.
Exactly.
And if something goes wrong, it's much easier to roll back.
Right. You haven't impacted everyone yet.
Exactly. You've limited the damage.
Limited the blast radius.
Now, underlying all of this is the importance of monitoring.
Absolutely. Monitoring is key.
You got to know what's going on in your system.
In real time.
Right. In real time.
Yeah, you got to be able to see what's happening right now.
And not just react when things go wrong, but actually spout those warning signs.
Yeah. Be proactive, right?
Proactive.
Find those little issues before they become big problems.
So what does good monitoring look like?
Okay, so you got to collect data on all the important stuff, like how much CPU you're using, how much memory is being consumed, what's the network traffic like, how much disk I/O is happening.
Okay.
But it's not just about the hardware level stuff. You got to look at the application too. Things like error rates, how long are requests taking?
Okay. Latency.
Yeah, latency, that's a big one.
Yeah.
And, you know, are any queues getting backed up?
Right. Are things getting clogged up?
Exactly.
And then once you have all this data, you need to figure out what's normal.
Yeah, you need to set some thresholds right.
Right. So you know when something's out of whack.
Yeah. And then you set up alerts.
Right.
So if something goes above or below those thresholds, you get notified right away.
And this can help with the human error stuff too.
Right. Oh, absolutely.
Because if you see a spike in errors after a manual deployment, that might tell you that something's wrong with the process.
Yeah, maybe the documentation isn't clear enough.
Right.
Or maybe people need more training.
Or maybe the tools are too complicated.
Exactly.
So it's not just about finding technical problems.
No.
It's about understanding how humans are interacting with the system.
Yeah, right.
And then, you know, making improvements based on that.
Yeah, it's all connected.
Now, I want to talk about something that sounds a bit crazy.
Oh, yeah. I think I know what you're going to say.
But I've heard about this idea of intentionally introducing faults into a system to actually make it more reliable.
It sounds crazy, but it actually makes sense.
It does sound counterintuitive.
Yeah.
So how does this work?
Okay. So the idea is that by deliberately breaking things in a controlled environment, you can find those hidden weaknesses in your system.
Okay.
You know the stuff that you wouldn't find just by testing normally.
So it's like a stress test.
Yeah, exactly.
But instead of just pushing the system to its limits, you're actually trying to break it.
You're trying to break it on purpose.
But in a safe way.
Yeah, in a controlled way.
So you can see what happens.
And learn from it.
Can you give me an example?
Sure. So let's say you have a system that's made up of a bunch of different services, and they all talk to each other over the network.
Right, a distributed system.
Exactly. So you could use a tool to simulate network problems.
Okay.
Like you could introduce some latency.
Right, so make the network slow down.
Yeah. Or you could even disconnect services completely for a short time.
Wow. So you're intentionally creating these mini outages.
Yeah, just to see how the system reacts.
And by doing this, you can learn a lot.
Oh, yeah. You can see if your timeouts are set correctly.
Right.
You can see if your retry mechanisms are working. You can even see if your monitoring system is catching these problems.
So you're not just hoping that things will work.
No.
You're actually testing it.
You're verifying it.
And this is all happening in a non-production environment, right?
Of course. Yeah, we don't want to break the real system.
So no customers are affected?
No.
It's like a fire drill.
Yeah, exactly. A fire drill for your software.
And this kind of approach, it's called chaos engineering.
That's right. It's a pretty cool name, isn't it?
It is a cool name.
Yeah.
And I think if you can talk about this in an interview,
right,
if you can show that you understand this kind of thinking, that's really impressive.
It shows you're thinking at a high level.
Right.
You're not just a coder, you're an engineer.
You're a problem solver.
Yeah. You're thinking about the big picture.
So to wrap up, it sounds like when you're preparing for that senior software engineer interview, you need to show that you understand that reliability is not just a nice to have.
Yeah.
It's fundamental.
It's baked into the design from the start.
Right. It's not something you add on later.
No.
It's part of the foundation.
Yeah. It's in the DNA of the system.
And you need to show that you're thinking proactively about how to build systems that can handle the real world.
The real world with all its surprises.
So for anyone out there who's getting ready for these interviews, think about your experiences. Have you faced these challenges?
Right.
How did you solve them?
Yeah. What did you learn?
And how would you design a system that's truly reliable?
That can stand up to anything.
Because that's what they're looking for.
That's what makes a senior engineer.
That's what sets you apart.
Absolutely.
So good luck out there.
Yeah. Good luck.
And we'll see you next time.
See you later.
On The Deep Dive.
All right.